Now we will see the nodal analysis. Before learning the nodal analysis, we have to see some steps or conditions while applying the nodal analysis. Simply, suppose this is the first condition. If we are considering this node is A and this node is B, and the voltage at node A is VA and the voltage at node B is VB, and current flowing like this from the node A to node B, and I am considering it is I, then we have to find this current which is flowing through the resistor R. In that case, we are considering simply it is I is equal to initial voltage minus final voltage divided by the resistor. So simply it is VA minus VB divided by R. This is the current flowing through the branch. This formula we are using only when we don't know the polarities of the VA and VB. But the second case is V1 and V2 are having the polarities plus minus minus plus like this. In that case, suppose the current flowing through this branch is I and we have to find the current I. Then see here, this current which is flowing like this plus to minus, therefore it is fall in voltage and we are considering it is minus V1. Then this current through the V2 it is minus to plus, therefore it is rise in voltage and it is plus V2 divided by R, which is the current flowing through the branch. Similarly, suppose this is the voltage source and I am considering the direction of the current is like this and the current is I. So simply I is equal to, see here current flowing from minus to plus, so it is rise in voltage and it is plus V1, and here again the current flowing from minus to plus, therefore again it is rise in voltage, therefore it is plus V2 divided by R. This is the current flowing through this branch. The fourth example is same as that of the third. Then we will see the steps which we have to use in the nodal analysis. See here, the first step is we have to consider the different nodes or n number of nodes. Simply we have to consider the n number of nodes. In that one node we are considering it is a reference node. Suppose this is the circuit. In that there are different nodes. Node is nothing but the combination of the branches. So this is the node and this is again node. Suppose this node is A and this node is B, and suppose this node is C. See here, the node C is connected to the negative terminal of the battery and we are considering the node C is the reference node. Node C is the reference node. That means it is connected to the ground terminal, or voltage at C will be equal to 0 volt because it is at the ground potential. Then so therefore we are not considering the reference node in the circuit, we are considering only the node VA in the B. Suppose in next step we have to identify the voltages at the node. Suppose at node A the reference voltage is VA and at node B the voltage is VB. Then the next step is we have to consider the directions of the current in the branches, because in the node analysis we are using the KCL. So simply in the nodal analysis we are considering the actual direction of the current. That means suppose this is the positive terminal, that means current flowing from the positive terminal. That means suppose the first current which I am considering is I1, and this current coming to the node A and distributed in the two branches like this. Suppose this current is I2 and this current is I3. Again see here, the I2 current coming to the node B. Similarly here is the positive terminal of the battery and current again flowing from the positive terminal, and this current I am considering it is I4. Then the addition of this two current, which is I2 which is coming to the node B and I4, it will be go in the 2 ohm resistor branch. So simply we have considered here the different direction of the current, and as the definition or as a second step, apply KCL at each node. Simply we are applying the KCL at node A. The first step is apply KCL at node A. Simple definition of the KCL is incoming current is equal to outgoing current, or in that case, see here the I1 is incoming current, I2 and the I3 are outgoing current. So simply I1 which is equal to I2 plus I3, or we can consider like this. Suppose there is I1, this plus I2 will be at left hand side, will be minus I2 minus I3 is equal to 0. In the next step we are going to consider the incoming current. Incoming current is positive and the outgoing current is negative. See here, incoming current is I1 which is positive, and the I2 and the I3 is negative. So similarly, then as we have seen the different steps or the conditions before, see here the current I1, this current I1 which is flowing from this terminal or this voltage source to a VA. So simply the current which is flowing like this, minus to plus, so 20 is the initial voltage. So simply for the current the equation will be like this: current flowing from minus to plus, therefore it is rise in voltage, and we are considering it is plus 20. So simply 20 minus final voltage is VA. VA is having no any polarities, therefore we are considering it is minus, because it is final potential. This is the initial potential, this is the final potential. So simply minus VA divided by the resistance is 1 ohm. So this is the current I1. Then we are going to find the current I2. Simply minus, see here, I2 current flowing from A terminal to the B terminal. That means initial voltage minus final voltage divided by resistance. So simply I2 will be VA minus VB divided by 0.5. VA minus VB divided by 0.5. Then this is the I3 current. I3 current which is flowing through the 1 ohm resistance. That means this is the starting terminal, this is the final terminal. That means initial voltage minus final voltage divided by resistance. So simply see here, the initial voltage is VA and final voltage is VC, suppose, but VC is 0 volt because this is at the negative terminal, or it is the ground potential. So simply VA minus 0 divided by 1, which is equal to 0. Then suppose by solving this equation we get see the meaning of the 0.5 is simply the which is equal to 1 by 2. So simply this 2 will be go at the numerator. So simply it will be 20 minus VA minus this 2 will be multiplied to the VA minus VB. So simply it is minus 2 VA plus 2 VB minus VA, which is equal to 0. The final equations will be, it is 4 VA minus 2 VB, which is equal to 20. Suppose this is the first equation. Now we have to apply the KCL at node 2 or at node B. This is the first equation, and always remember that by the nodal analysis we are going to find out the voltages at different node, and after finding the voltages by applying the Ohm's law at different branch we are going to find out the unknown currents. So simply we are now going to apply the KVL at the node. KCL. Apply KCL at node B. See here, we are considering the incoming current is positive and the outgoing current is negative. Here the I2 and the I4 are the incoming currents. So simply I2 plus I4, and the I5 is outgoing current. I2 is incoming current, I4 is incoming current, and the I5 is outgoing current. So simply it is minus I5, which is equal to 0. Then we are applying the different conditions. Simply see here, the I2 current which is flowing from A terminal or A node to the B node. So simply it is initial voltage minus final voltage divided by the resistance. So finally equation for the I2 is VA minus VB divided by 0.5. VA minus VB divided by the resistance. Then for the equation for the I4 is, see here, the I4 current flowing like this in that direction, that means 20 volt source to the VB, and through the 20 volt source current flowing like this minus to plus, therefore it is rise in voltage, and we are considering it is higher potential, or it is positive. So simply initial voltage is 20 volt and the final voltage is VB. So simply it is 20 minus VB divided by the resistance is 1 ohm. And then the equation for the I5 is current flowing like this from the B terminal or node B to the node C. So simply it is initial voltage minus final voltage divided by the resistance. So initial voltage is VB minus VC divided by resistance is 2, which is equal to 0. And by solving this equation we get, this is the 0.5 is nothing but the 1 by 2 will be multiplied at the numerator. So simply it is 2 VA minus 2 VB plus 20 minus VB minus, so simply here is 2, so 2 is nothing, 1 by 2 is nothing but the 0.5, so simply it is 0.5 VB plus 0.5 VC, which is equal to 0. And after simplifying this equation we get, simply it is 2 VA minus 3.5 VB, which is equal to minus 20. Suppose this is second equation. So by the first and the second equation, and we know the first equation was it is 4 VA minus 2 VB, which is equal to 20. This was our first equation. So by these two equations we get the values of VA and the VB. So simply we are solving this equation is the calculator, in scientific calculator, and we get the values of VA and VB. So simply VA is equal to, we get, it is a 12 volt, and VB which is equal to again 12 volt. By solving these two equations we get the values of VA and VB. So similarly, suppose we have to find the current through the problem which we have seen, the question of this circuit is calculate the current through a 2 ohm resistor for the network shown. So simply the 2 ohm resistor is here, that means we have to find the current I5. So through the current, or through the resistance 2 ohm, the current I5 is flowing, and I5 is equal to VB minus VC divided by 2. So simply it is VB minus VC divided by 2, and we know the voltage VB is 12 volt. Similarly, which is equal to 12 minus 0, because VC is the reference voltage, so it is 0 divided by 2, so which is equal to 12 upon 2 is 6 ampere. That means current through a 2 ohm resistor is 6 ampere. Thank you.